This is numbers 19 through 24. So on number 19, we're supposed to be simplifying completely. You're looking for like terms. So here my coefficient of this one is a 5. Here my coefficient is a 6. Here my coefficient is 2. Here my coefficient is -4. Whatever comes behind each of those coefficients needs to be an exact match for us to be able to combine them. If you'll notice, behind the coefficient of 5 and 6, we have an exact match. Therefore, we keep the radical of 3, but we are allowed to go ahead and add 5 plus 6 together. 5 plus 6 is 11, so 5 square root of 3 plus 6 square root of 3 gives me 11 square root of 3. Then we do the same here. Notice that behind the coefficients of 2 and -4, we've got an exact match, the square root of 7. So we leave the square root of 7 alone. And now we do 2 minus 4, which is -2. So when we combine these two together, it gives me -2 square root of 7. Now look, we've got a coefficient of 11 and -2. Does what comes after them match? No, those are not the same things, so that would be my final answer. Alright, if you look at number 20, you'd be tempted to say that that's your final answer, but be careful because we should simplify the square root of 27 km first. So we're going to go ahead and do that to the side. 27 can be broken down into 9 and 3. And 9 can go into 3 and 3. So when we simplify the square root of 27 km, that's 3 times 3 times 3 km. We're looking for pairs, which is this one here. We get to pull it out. When we pull it out, we get a 3 on the outside. We're done with that. Square root of 3 km on the inside. So I'm going to go ahead and bring down 7 square root of 3 km minus, but now I'm going to replace this right here with what I just found it to be, 3 square root of 3 km. Now look behind the coefficient of 7 and -3. Do we have an exact match? This has a square root of 3 km. This has a square root of 3 km, for sure. So now you want to keep the square root exactly the same, 3 km. And all we have to do is combine our coefficients by doing 7 minus 3, which is 4. So that would be my final answer. Alright, same thing on 21. We want to make sure we simplify everything completely. So if you'll notice here, we've got to take that 20 and break it down, which would be 4 times 5. And then 4 would be broken down into 2 times 2. So when we have 2 square root of 20, which can be replaced with 2 times 2 times 5, x to the 5th, we can simplify that to be, here's a pair of twins that can come out. So 2 times one of these 2's is 4, square root of 5x to the 5th. Now that gives me 4 square root of 5x to the 5th. Now by the way, we can simplify this, but I'm going to show you something here. If I replace this here with 4 square root of 5x to the 5th and bring down this term right here, 5x to the 5th. Notice behind these two coefficients is an exact match. So I leave the exact match, 5x to the 5th, and I combine my like terms. 4 plus 3 is 7. Now, let's go ahead and clean this up. So we have 7 square root of 5. How many x's? We got 5 of this. And we're looking for the square root, so sets of 2. How many do I get to take out? 1, 2. So that would be 7. There is the x squared, the 2 that I took out. Inside would still be a 5 and an x. Whether you simplified the x to the 5th up here or here, it actually did not matter. You would still get the same answer. All right, on number 22, we are going to be multiplying. Remember, we multiply the coefficients together, so that would be 2, 4, and this invisible 1. So 2 times 4 times 1 is 8. Then we multiply the radicands together. So 6 times 8 times 3. But remember, we're going straight for prime factorization, so we don't need to multiply this inside number together. Rather, let's break 6 down into 2 times 3. And then 8 can be broken down into, if we did 8 over here, remember that's 2 times 4, and that's 2 times 2, so 8 has 1, 2, 3 2's. And then we have this 3 on the end. So this is 6, this is 8, that's the 3. Now let's put this in numerical order, so it'll help ourselves out. So I see 1, 2, 3, 4 2's. I see 2 3's. and we're looking for the square root, so we're looking for sets of 2, sets of 2, sets of 2. Everything's going to come out. So on the outside, I have 8 times 2 times 2 times 3, and now I have used one of each of these. So now you just need to multiply your final answer. So 8 times 2 is 16 times 2 is 32 times 3, 96. And that would be our final answer. On number 23, remember we want to distribute that square root of 5 to both terms. So we would have square root of 5 times that 3 square root of 5. Bring down that subtraction sign and go back to the beginning. Square root of 5 times 4 square root of 3. So there, that square root of 5 got distributed to both. Now there's an invisible 1 in front, so 1 times 3 is 3. And then we would have here, that would give me 5 times 5, which is important because it's a twin. Minus, again there's an invisible 1 here, so 1 times 4 is 4. And then on the inside here I'd have 5 times 3. This is a twin, which means it can come out. So that makes it 3 times, just get to keep one of them, 5. Minus 4. Notice that these are not twins, so we can go ahead and multiply them together. 5 times 3 is 15. So now 3 times 5 is 15 minus 4 square root of 15. Now look, my coefficients are 15 and negative 4. Is right behind what they both have an exact match? No. This 15 is missing a square root or a radical. So that is my final answer. They cannot be combined. On number 24, whenever you see something that's squared, what that means is 5 square root of 3x times itself, 5 square root of 3x. So we do the same thing, multiply your coefficients. 5 times 5 would be 25. And then on the inside, I get 3x times 3x, which, by the way, is a twin. So I get to pull out just one of those. So 25 times just one of those 3x's will make this a 75x. And that would be my final answer.